Welcome to 2.3. Today we're going to talk about the limit laws. Let me remind you of the two important limits we talked about last time. The limit of a constant is a constant, and the limit as x goes to c of x is just c. Now we can combine those two limits with these limit laws that I'll let you read on your own to take all kinds of limits. So rather than read through those, what I'm going to do is show you some examples of how you would use those. So substitution examples, we can replace x by c and nothing bad happens, and that's how we'll take the limit. So in this first example, I want the limit as x goes to -1 of this polynomial here. Now I can just plug -1 in for x and nothing bad will happen. And as soon as I do that, I drop the limit sign because that means you've taken the limit. And then I evaluate that number and I get 5, and that's my limit. It's that easy. Okay, next one, limit as x goes to -3 of that square root. So I take square root -3 quantity squared plus 1, which is root 10. Okay, two more, a fraction, and I'm not going to be dividing by 0. When I take the limit as x goes to 2, on top, I'm going to get 4 plus 2 plus 3. And on the bottom, I'm going to get 4, and that's 9/4. Okay, last one, as x goes to pi over 2, sine x goes to 1 because sine of pi over 2 is 1. So 2 plus 4 is 6. Okay, that's not the norm. Usually something bad's going to happen. So we're going to get 0/0 typically. And there's three things we can try when that happens. We can try factoring and canceling. We can try rationalizing if there's a square root. Or we can simplify a complex fraction. And I'm going to do an example of each one. All right, first example. When I plug x equal 1 in, I get 0/0. That's a do more work. All right, so the work I'm going to do is factor. This is the limit as x goes to 1 of x minus 1 times x plus 5 over x minus 1. Now, you have to carry along that limit sign. These x minus 1s cancel because we're not actually going to let x equal 1 yet. So this is the limit as x goes to 1 of x plus 5. Now if I use substitution, nothing bad happens. 1 plus 5 is 6, and that's my limit. Now, it's very important to carry along the limit until you take it, because I'm not saying that x plus 5 over times x minus 1 over x minus 1 is x plus 5. They're not, but their limits are equal. If you graph those two functions, one is a line, and one is the exact same line with a hole punched out at x equal 1. Okay, why don't you pause the video and practice this one? Okay, hopefully you did that. When you plug in -3, you see you're going to get 0/0, which is a do more work. So this is the limit as x goes to -3 of x plus 3, and the denominator factors as x plus 3, x plus 1. So the x plus 3's cancel, and that's the limit as x goes to -3 of 1 over x plus 1, which is -1/2. See where I dropped the limit sign? Right there, I took the limit. As soon as you do substitution, you're taking the limit. Okay, a rationalization problem. I've got a square root, and I'm getting 0/0. So what I'm going to do is rationalize the denominator. Okay, and I'll do that by multiplying by the conjugate. Now, if you're not familiar with what conjugates are, I've got them described over here in a box. But I've started out our solution, and you can see I'm multiplying by 1. This is 1. But I'm writing 1 as the conjugate of this term divided by itself. So this is a binomial, that's a binomial, this is a binomial, that's a binomial. So when we multiply, I'm going to leave the top alone. The limit as x goes to 1 of x minus 1 times root x plus 3 plus 2. In the denominator, I'm going to do FOIL. So I get x plus 3, and then the middle term is -2 times root x plus 3, and the other middle term is +2 times root x plus 3, and then I get -4. Now that was the goal. because see, the inside terms cancel. And so we've gotten rid of the square root. That's the limit as x goes to 1, x minus 1, I'm leaving the top alone. And in the denominator, I've simplified to x minus 1. Okay, now I can cancel those x minus 1s. I'm no longer dividing by 0. I get root x plus 3 plus 2. Now I can take the limit, drop the limit sign, square root of 4 plus 2 is 4. All right, and now we'll do one where we get a complex fraction. Okay, so we're going to find the limit of the difference quotient for f of x equals 1 over x. Geometrically, that will be the slope of the tangent line to 1 over x. Okay, so this is the limit as h goes to 0. F of x plus h is 1 over x plus h. That h has to be in the denominator. Minus f of x is 1 over x, divide by h. All right, that's going to be 0 over 0 if I just let h equal 0, so I have to do more work. And what I'm going to do is multiply by the least common denominator. So I'm going to multiply the top by x times x plus h, because that will clear fractions. But if I do that to the top, I better do it to the bottom. So multiplying by 1. Okay, now that's the limit as h goes to 0. I need to distribute to both of these fractions. When I distribute to the first fraction, I get x. When I distribute to the second fraction, I get x plus h. You need parentheses because you have to distribute the minus. The bottom I'm just going to leave as x times h times x plus h, factored. Okay, now let's clean up the top. That's the limit as h goes to 0 of x minus x is 0, so I get negative h over x times x plus h. Now I can cancel those h's. That's the limit. Yes, you have to carry the limit the whole time. Limit as h goes to 0 of negative 1 over x times x plus h. Now I can let h equal 0 because I'm going to get negative 1 over x squared. And actually, we just found a derivative. So we've already started doing calculus. Okay, I'm going to do one more example of piecewise limits, and then I'm going to let you on your own read about the squeeze theorem. Okay, sketch F to find the limits. F of x is a piecewise defined function. Between 0 and 2, the function is y equal 3 minus x. The y equal is out here. So 3 minus x is a line. I'm going to need a solid dot there. We've got slope negative 1. Hollow dot there, because this is strictly less than 2. At 2, the function is 2, so that's a single point. And then after 2, the function is y equal x over 2. So that would start here and then go up with slope 1/2, like that. All right, f of 2 is 2. The limit, the left-hand limit, remember that minus over the 2 means left-hand limit of f. So we're going to come in at 2 from this side, and we see the y values are approaching 1. And if we come in at 2 from the right-hand limit, we get 1 again. And so since the left-hand limit and the right-hand limit are equal, that's the limit. Okay, that is the end of this section.